All right, so practice problems for midterm 2. First problem, simplify the difference quotient for the following, which is f of x plus h minus f of x all over h for the following function, f of x equals 3x plus 7. And I do want to emphasize on your test, unless it specifically says so, you need to show work. I would encourage everybody to go look at the homework assignments I've graded. Some of you are getting problems, the answer is right, but not showing any work and not getting very much, if any, credit. So it's really, really, really important that I can see that you understand the process of how to get the answer, not just that you have the right answer. Right, so like if you just wrote this on an exam, that's the right answer, you will get 0 credit because I don't know how you got there. I need to be able to know how you got the answer. Unless, of course, I mean, there are some exceptions where something might be really super obvious. And for the most part, if something doesn't seem really super obvious, you should show the work. You should just, and if you're not sure, show the work. And if you're still not sure, you can always send me an email. Be like, James, do I need to show work for this? I'll be like, yes, show work. So show the work. So we're going to write f of x plus h minus f of x. So if you want, I think it's a good idea to over here say, oh, well, f of x plus h is, instead of 3 times x plus 7, it is 3 times x plus h plus 7. And then that's what's going to go here for, right? F of x plus h is first, minus f of x is second. So it's going to be f of x plus h is 3 times x plus h plus 7, minus all of f of x. It's really, really important that you put parentheses or brackets around f of x so that we know that we have to distribute the minus sign. Also, when you're writing the difference quotient, we can't just write the top and then at the end say divided by h. We have to write divided by h each time. That is necessary. So then we're going to simplify. We're going to get 3x plus 3h plus 7. And then we're going to distribute the minus sign to each term. So we're going to get minus 3x minus 7 all over h. The 3x and the minus 3x cancel. The 7 and the minus 7 cancel. So we're left with 3h over h, and then h divided by h is 1. So you get 3. I really should say 3x minus 3x is 0. 7 minus 7 is 0. So when you subtract them together, they cancel out and leave behind nothing. H divided by h also cancels, but when you're canceling with division, you're canceling out and leaving a multiply by 1 behind. So you get 3 times 1, which is 3. Okay, let's do the other one. So let's look at f of x equal to, what do we got here? F of x is 2x squared minus 3x plus 9. And let's go ahead and write down what f of x plus h is. So f of x plus h, again, I'm just taking everywhere there's an x, and instead I'm leaving myself a parentheses. A parentheses where I'm going to fill in an x plus h. So then we know we have to write the difference quotient is what we have to simplify. So f of x plus h is this, minus f of x is that. So it's going to be this. You don't need the brackets around it, then putting the brackets around it kind of emphasize that they're 2 different pieces. So there's your f of x plus h minus your f of x, 2x squared minus 3x plus 9, all divided by h. Okay, so now I'm going to multiply this out. So multiplying this out is kind of a 2-step process, actually. First, I'm just going to multiply out the x plus h squared. So x plus h times x plus h, right? X plus h squared is x plus h times x plus h, which is x squared plus xh plus xh, which is plus 2xh plus h squared. So we end up with 2 times x squared plus 2xh plus h squared. Then we can distribute this minus 3, we get minus 3x minus 3h plus 9. And it's always going to be minus f of x, so you're almost always going to have to distribute this minus sign to each term in f of x. So minus 2x squared plus 3x minus 9, all divided by h. This pen seems like it's on its last legs here. Yeah, sure. So this is going to be equal to, so negative 3x plus 3x is 0. 9 minus 9 is 0. And then I'm going to distribute this 2. So we get 2x squared plus 4xh plus 2h squared minus 3h minus 2x squared. Still all divided by h. A reminder, our ultimate goal is to make this original h in the denominator. We want that to cancel out. But before I can get there, I need all the non-h things in the numerator to cancel out. Isn't it 4xh? This, yeah, it is 4xh. That's a 4. Yeah. So then 2x squared and negative 2x squared, those cancel out to 0, right? 2x squared minus 2x squared is 0. And then the rest of the terms have an h. You can just divide these things by h. I personally like to factor out the h. So I've got h times 4x plus 2h minus 3. Do be careful here. I saw a couple people in the homework on this stuff kind of like do this and then cancel this h, but still leave this h here, and then try and cancel that h with that h and get like 4x plus 2 minus 3, which is not right. The final answer, this h divided by this h is 1. So they cancel out and leave behind a 1. And then you've just got 4x plus 2h minus 3. Sometimes, a lot of the time actually, your final answer is going to have an h in it. Your job, your only job really, I mean, it's the job of the problem, but your only job is to make sure that this h in the denominator somehow cancels out. After you cancel out that h, you should stop. That is the last step of the problem. This is, I should say, this is definitely going to be on your midterm. It'll probably also be on your final, because this is a super important calculation that you do a lot of in whatever calculus class you take, right? This is literally leading us to the definition of the derivative, which is kind of like all about what the first quarter is, what the first quarter calculus is all about. So it's important. You need to be able to do it. All right, let's move on. So question 2 on this midterm review is like 10 graphing problems. So we might not do all, so maybe we'll do some of them and then maybe we'll skip around a little bit and then come back to them. Let's do like the first, we'll do at least the first 4 or 5. So let's graph. So here's what the instructions are. Graph indicating all important features, which means intercepts, asymptotes, vertices if there are any, centers of circles if there are any, anything else that might seem important, holes, right? So important points is really kind of like anything that should be taken note of. So let's look at this first one. F of x is equal to x cubed minus 6x squared plus 9x. Okay, it's a polynomial of degree 3. There aren't any other important points, right? If it's a degree 2 polynomial, like a parabola, then we should find the vertex. But any higher degree polynomial doesn't have any sort of vertex or anything that we look for. So I'm going to find all the things. I guess I should also, you don't have to find the end behavior, but I like to. But let me actually not find the end behavior, and then we'll kind of talk about it. So I'm going to find the y-intercept. I'm going to set x equal to 0. F of 0 is 0 minus 0 plus 0. Oh, that's 0. The x-intercepts, we're going to factor this as much as possible. So I should say we're going to set y equal to 0. we know we can factor out an x. Sum of x times x squared minus 6x plus 9, 0. And then you can factor this further. This factors is x minus 3 times x minus 3. So be careful here. If you do it this way, you might make the mistake of saying that x equal to 3 is a multiplicity 1 intercept. It is not, right? Because this is x minus 3 times x minus 3. This is x minus 3 squared. So we get x equal to 0 with a multiplicity of 1, and x equal to 3 with a multiplicity of 2. So you really do need to, if you have a factor that's repeated, you need to combine them all into one piece and write the to a power.
James,
Graphically, here's what we have. We have an intercept at 0 and an intercept at 3. And that's kind of all we have. Now, if we knew the end behavior, we could graph this. But since we don't, and I'm pretending like we're not going to find it, I'm gonna pick another point. So I'm gonna pick like x equal to 1. If I pick 1, I can plug it in here and get 1 minus 6 plus 9, which would be 4. Or you can plug it in here and get 1 times 1 minus 3 squared, which is 1 times negative 2 squared, which is 1 times positive 4, which is 4. Either way, when you plug in 1, you get 4. I know that's not to scale. That's fine. Your x and your y-axis don't have the same scale. What I know is that means I'm going to go up like this, and then I don't know if that's actually where I'm turning around. I don't care. You shouldn't care either. In fact, if you know the point that it's turning around, it means you probably used Desmos to graph the thing, because we don't have the tool, or using calculus, right? But like, if you're finding the point where it's turning around, that's not something we have the tools yet to be able to find without a graphing calculator. Not that you're not allowed to kind of see what things look like graphically, but the work you're submitting should be your own, right? Yeah, we can all look at the graph, copy it down. Are we learning anything? Not really, right? The whole point of this class is that you're learning the stuff so that you're able to do it in future classes and able to understand what's going on. So yes, we also want to pass the class, but really I want you guys to learn the material. So when you're taking the exam, keep that in mind. I should say, right, like, so at 0, 0, we cross, at 3, 0, we bounce. So this is what it looks like. We also could have found the end behavior, right? The degree is odd. The leading coefficient is positive, which means it's down on the left, up on the right. Oh yeah, down on the left, up on the right. Okay, more graphs. That's not a good idea. Okay, cool. A good idea for a question. Okay, so let's look at the next one. We want to graph f of x equals 8 to the x plus 1 minus 4. Okay, so I'm thinking about the parent graph 8 to the x, which is an exponential. Right, here's 8 to the x. Goes to the y-intercept of 0, 1, and it's not very interesting. This graph is going to shift 1 to the left and 4 down. So I'm going to find the things. I'm going to find my, let's start with the intercepts. So y-intercept, I'm going to set x equal to 0. And if x equals 0, y is going to be 8 to the 0 plus 1 minus 4. 8 to the first is 8. 8 minus 4 is 4. Great. Now, here's something also that's important. So sometimes it kind of makes sense to actually start doing the graph even though you don't have all the pieces. So there's my y-intercept. I also know that my horizontal asymptote is going to be down 4, right? Normally it'd be y equals 0, but you shifted it down 4. So it's going to be at y equals -4. And I haven't written that down yet. I guess I could. But the point I'm trying to make, knowing that the horizontal asymptote is y equal to 0 minus 4, is that it means we're going to have an x-intercept. If you take an exponential graph and you shift it down, all of a sudden you've introduced the crossing of the x-axis. So I'm going to find the x-intercept by setting y equal to 0. So I've got 0 equal to 8 to the x plus 1 minus 4. We're going to isolate the exponential thing. So I'm going to add 4 to both sides. So 4 equals 8 to the x plus 1. Now you have a couple options. I think the best option here is to write both sides as powers of 2. There are other options. You can take the log base to a side of both sides. You can also take the natural log of both sides, but the problem with that is that, let me show you. Take the natural log of both sides. It's harder to see what the nice answer is. Natural log of 4 equals the natural log of 8 to the x plus 1. Bring down the power. Natural log of 4 equals x plus 1 times the natural log of 8. Divide by the natural log of 8. So natural log of 4 divided by natural log of 8 equals x plus 1. Subtract 1. So that x equals the natural log of 4 over the natural log of 8 minus 1. Okay, but it's hard to see. How did I find the horizontal asymptote? I found the horizontal asymptote by knowing that usually an exponential function has a horizontal asymptote of 0, and we shifted it down 4. So we did 0 minus 4. It's maybe not super easy to see that this is equal to -1/3. At least not without calculating. But the way we want to go here is say, oh, look, 4 and 8 are both powers of a common base, 2. 4 is 2 squared, and 8 is 2 cubed. So then we can say that 2 to the second equals 2 to the 3 times x plus 1. And then if the bases are the same, the powers have to be the same. So that 2 equals 3x plus 3. I distributed the 3. And then 2 minus 3 is -1. And then x equals -1/3. Now, I actually probably wouldn't draw that in there. First, what I would actually do is I would say, okay, I know I'm going to have some x-intercept that's pretty close to the origin. I'm just going to try and draw my graph now. Yeah, not the best graph. There's my intercept, -1/3 0. It's okay if your graph is not perfect. It just needs to have the right features, right? So what I want to point out here is that even though my graph is pretty steep, there is no vertical asymptote. An exponential function never has a vertical asymptote. In a similar way, a logarithmic function never has a horizontal asymptote. Okay. Even though it looks super steep, right? It looks like, you're like, James, are you sure? Yes, I'm sure. There's no vertical asymptote there. Questions about this one besides, or I should say other questions about this one? Drop pens everywhere. My volume is on, right? I'm always worried like my volume's off. People are like, James, I'm saying stuff. If you're ever saying something and I'm not responding to what you're saying, it's because my volume is off. So if that ever happens, write in the chat and be like, hey, James, your volume's off. Turn it on. It's usually not the case, but once or twice it has happened. Okay. Where did I get the 2 squared? Sure. So what I was doing was I was taking this equation, 4 equal to 8 to the x plus 1, and I was trying to solve for x. And one common way of solving for an exponent, if both of these numbers are powers of a common base, and they are. 8 and 4 are both powers of 2. 4 is 2 to the second, 8 is 2 to the third. So we rewrote them. We rewrote 4 as 2 squared, and we rewrote 8 as 2 cubed. And then it's 8 to the x plus 1, so it's 2 cubed to the x plus 1. That's what's happening there. All right. Let us look at the next one. Change up the colors. I wish. I wonder if I can. So yeah, it is, and it's what personally I think it's the best way to do it. But there are of course another way. So another way you could do that, which I also think is good, if you have 8 to the x plus 1 equal to 4. Instead of writing both sides as powers of a common base, you can take the logarithm with that common base of both sides. So instead of taking the natural log of both sides, which is normally fine, the problem with the natural log of both sides, again, is that it leads to this kind of this answer that really requires us to use a calculator, which I know in this day and age is normally fine, right? Calculators are bound. But in an in-person math class, you might actually have to take a test where you couldn't use a calculator. So to answer how to find the horizontal asymptote, right? We know, in fact, let me write it over here. So, right, normally, if I had, so I'll answer both questions here. So if you were graphing, like y equal 3 to the x, any exponential function, if you haven't shifted it, has a horizontal asymptote of y equals 0. So I was going to graph that one. It would just look like that. If I shift it up or down, that's going to shift the horizontal asymptote. So if I was going to graph, say, instead, y equal to 3 to the x minus 3, that would shift my horizontal asymptote down 1, 2, 3. Sorry. So this function here, right? This is and that's the intercept 0, 1. Everything gets moved down 3. So instead of having an intercept at 0, 1, I get an intercept at 0, negative 2. Instead of having a horizontal asymptote of y equals 0, I have a horizontal asymptote of y equals negative 3. But it's really just knowing that we had one at 0 and knowing that we have to shift it down as much as the graph shifts down, or shift it up as much as the graph shifts up. And then, oh, look, there's an x-intercept. We would have to find it. It would be 1, right? If we set y equal to 0, 3 to the x minus 3 equals 0, that means 3 to the x equals 3. Well, that means x has to equal 1. Back to this question. Another way to solve this, if you see that they have a common base, 8 and 4 are both powers of 2, you can take the log base 2 of both sides. You can take the log base 2 of 8 to the x plus 1 and the log base 2 of 4. I'm going to use the power rule for logarithms to bring that x plus 1 down in front. So x plus 1 times log base 2 of 8 equal to log base 2 of 4. Okay, help me out. What is log base 2 of 8? What number is that?
Would it be 3?
Definitely, right? Because 2 to the third equals 8. Somebody else, what's log base 2 of 4?
2.
Right, because 2 squared equals 4. So then we're solving x plus 1 times 3 equals 2, which is the same equation we were solving when we did it this way. X plus 1 times 3 equals 2. And the solution is the same, right? You get 3x plus 3 equal to 2, 3x equals negative 1, x equals negative 1. So these are the ways that we usually solve these problems, because often we are artificially imposed artificially we were told we can't use calculators. So, right, you could also solve it this way. I will say one issue with doing it this way, if you do use a calculator, is that if you start using decimal approximations too soon, you're going to get not the exact right answer. Right, the answer should be -1/3, not -0.33 or right -0.335. Like maybe you get some weird approximation that's kind of a little bit off because you approximated too soon. Right, if your answer is not exactly the right number, I'm going to know you did a decimal approximation too soon. Right, so definitely your answers should be the nice numbers they're supposed to be, not weird funky decimal approximations. And most of the time, when I'm giving an exponential function and I shifted up or down, I've usually shifted in such a way so that the bases, the numbers do have a common base so that you can solve it the way we just talked about. All right, next one. Let's look at the graph of f of x equal to x divided by x squared minus 16. I know what I was going to do. I was going to move this over here. One second. Yeah, sure, that's fine. There's a little bit, just a little bit of glare from my computer. And I'm like right here, there's some glare, and there's nothing you can do about it because can't teach with my screen not on. So yeah. All right. Oh well, sorry. So let's graph this one. So all the usual things: y-intercept, x-intercepts, vertical asymptotes, horizontal asymptotes, slant asymptotes if there isn't a horizontal asymptote. For a rational function, right? Only for rational functions. We look for slant asymptotes. If there isn't a, well, I should say, we'll talk about it. Y-intercept. X equals 0. Y equals f of 0, which is 0 over 0 minus 16, which is 0. Right? 0 divided by not 0 is 0. X-intercepts. We just set the top equal to 0. Well, that was easy. We got x equal to 0. Or you could, if you really wanted to, right, you could set the whole thing equal to 0. You could set x over x squared minus 16 equal to 0. But then you're just multiplying both sides with the denominator. So you're getting x on the left equals 0 times whatever is still 0 on the right. So you get x equal to 0. Vertical asymptotes, that's where we're setting the denominator equal to 0. This factors as x minus 4 times x plus 4, which is going to give me x equal to 4, x equal to negative 4. Sorry, let me take a quick journey. Just a couple things I've seen that I want to make sure they're mistakes that people don't make, if you can help it. So there's kind of like 3 different things here. There's x squared minus 16 is x squared minus 4 squared, which is x minus 4 times x plus 4. Whereas x plus 4 squared is x plus 4 times x plus 4, which is x squared plus 4x plus 4x plus 16, which is x squared plus 8x plus 16. And then in a similar way, x minus 4 squared is x squared minus 8x plus 16. And then x squared plus 16 does not factor. I think that's all I want to say there. Yeah, so just be careful, right? When you've got a difference of squares, it factors as one thing times the other thing. But then if you got something like x plus 4 squared, it becomes, right, this trinomial, x squared plus 8x plus 16. x minus 4 squared is x squared minus 8x plus 16, but there is a middle term. I think that's all I want to say, just to kind of be aware of all those kind of different things that kind of look the same. Could you turn to the other side? I'm going back to the other side, yeah. That's the plan. So we've got everything except for the horizontal or slant asymptote. So we have a horizontal asymptote. And we know we have a horizontal asymptote because the degree on top is 1, which is less than the degree on the bottom. Right, the degree on top is 1, the degree on the bottom is 2. Okay, so our horizontal asymptote is 0 because the degree on top is less. Right, our horizontal asymptote isn't 1/2. Right, it's not the quotient of the powers. It's the quotient of the leading coefficients if the highest powers are the same. If the highest power on top is less, the horizontal asymptote is just 0. Okay, now we can draw the thing. So let's see, I've got an intercept of 0. I've got vertical asymptotes at 4 and -4. I don't think you need to label these if you write them out, but you can. And then I've also got a horizontal asymptote of 0. So vertical asymptotes at -4 and 4, horizontal asymptote y equals 0. You shouldn't draw that in because it's already there. Oops, that's not what I want. And then the problem is I don't know if I'm above or below the x-axis. I do know that at this point here, my x-intercept, this came from having odd multiplicity, so we're probably going to cross. And my vertical asymptotes also both have odd multiplicity. So they're both going to be opposite ones, where one side's up, one side's down. I'm going to plot a few more points. I'm going to plot x equal to 1. So if x is 1, f of 1 is 1 over 1 minus 15, which is 1 over negative 15, which is negative 1/15. So if I plug in 1, it's going to get slightly negative. And then as I keep going to the right, I can't cross the x-axis again because I don't have any x-intercepts. So I have to keep going in this downward direction. On the other side of this vertical asymptote, well, it's an odd vertical asymptote, so we have to be going up this way. You could also pick another number like, say, 5. If you plug in 5, 5 over 25 minus not 16 is 5 over 9, which is positive. So you plug in 5, it's like positive 1/2. So like that. And then as you go out to the right, it has to get closer and closer to the horizontal asymptote. So the left is kind of going to do the same thing, except it's going to be the reverse of it because it's an odd function. You don't need to know this is an odd function, but if you did know, you'd be like, oh yeah, well that's just going to be up this way and this way. Or you could test points, right? You could test -1. If you plug in -1, you get -1 over 1 minus 16, which is -1 over -15, which is positive 1/15. And then you can plug in -5 and get -5/9. So that's what that graph looks like. And I feel like this is a good time to do another example. So even though this one isn't on the list, I'm gonna throw in an extra one here. So let's graph this next one. Let's graph f of x equal to 3x squared minus 3 over, what do I want to do? Sure, let's make it fun. Sure, we'll make it fun, all right. Okay, so sorry. So let's again. I want to make this. Let's make this x. Sorry, I want to. Yeah, sorry, brain. My brain's not quite right. Let's make this bottom part 2x squared. Sorry, brain work. Sure. 2x squared plus 8x plus 8. Yeah, that would be good. All right, so let's graph this thing. So usual stuff. Y-intercept. Set x equal to 0. If x is 0, f of 0 is going to be 0 minus 3 over 0 plus 0 plus 8. You know what I should have done, which I still can do, is I probably should factor this to make sure nothing cancels. Because if something cancels, there's going to be a hole. So let's do some factoring. From the top, I can definitely factor out a 3. I'm left with x squared minus 1. From the bottom, I can definitely factor out a 2. I'm left with 2 times x squared plus 4x plus 4. X squared minus 1 factors as x minus 1 times x plus 1. And x squared plus 4x plus 4 factors as x plus 2 times x plus 2, which is x plus 2 squared. That's going to help us graph this thing a little more easily. So to find the x-intercepts, we're going to set the top equal to 0. So I'm going to get 3 times x minus 1 times x plus 1 equal to 0. That's going to give me x equal to 1 or x equal to negative 1. Right, I don't set 3 equal to 0 because that doesn't get me anything. But x minus 1 equal to 0 gives me x equal to 1 with a multiplicity of 1. X plus 1 equal to 0 gives me x equal to negative 1 with a multiplicity of 1. Vertical asymptote. We set the denominator equal to 0, so we set 2 times x plus 2 squared equal to 0, and we end up getting x equal to negative 2 with a multiplicity of 2. So whatever our vertical asymptote is, both sides are either going to both go up or both go down. Oh, okay.
I have a good question.
Yeah, go ahead.
Do we have to do anything with that? Sorry, with that 3 that we took out, or that we factored from the numerator?
I'm not sure what you mean by do anything with. Like it needs to stay there, but it's not going to contribute to any sort of x-intercept.
Okay, because I think there's some examples that like we've done where we factor out an x and we set x equals to 0.
Sure. That's not x though. That's 3. If you set 3 equal to 0, there is no solution, right? 3 isn't 0.
Right. Okay. Thank you.
Yeah, if you factor out constants, we don't set them equal to 0 because they won't be. But if you factor out variables, then we definitely set them equal to 0 because they can't equal 0. Horizontal asymptote is what I really did this problem for. So for the horizontal asymptote, we know that the degrees are the same, right? The degree on top is 2, and it's equal to the degree on the bottom, which is also 2. The horizontal asymptote is not 1, right? It's not 2 over 2. The horizontal asymptote is the quotient of the coefficients of those highest power terms. So the horizontal asymptote is y equal to 3 over 2. The leading coefficient on the top divided by the leading coefficient on the bottom. Let's graph it. So let's see what I've got here. I've got a y-intercept of negative 3, 8, so that's not very negative. I've got an x-intercept of 1 and negative 1. I've got a vertical asymptote of negative 2. And I've got a horizontal asymptote at 3/2, which is between 1 and 2. And if you're James, you're going to start at your y-intercept and be like, okay, I'm going to hit this x point, and then I'm going to, well, since my x-intercepts are both odd multiplicity, I'm going to cross. And then get closer to my horizontal asymptote. If I had a 3x on the outside, yes, x equal to 0 would be an x-intercept because you can set 3x equal to 0, but then you can divide both sides by 3 and still just get x equal to 0. So yeah, if you had a 3x, for sure 0 would be an intercept. So I started here, hit my x-intercept, crossed, and then got close to the horizontal asymptote. Going to the left, I have to hit my x-intercept, cross, And then since I'm out of x-intercepts, I have to keep going in the same direction, right? I can't turn around and go down. I have to go up. Yes, I'm crossing my horizontal asymptote. Sometimes that happens. On the other side of this vertical asymptote, since we know it was an even multiplicity vertical asymptote, that means both sides have to go the same direction. Since one side's going up, the other side also has to go up. And then as we go to the left, it's got to get closer to the horizontal asymptote. Looks like all we're going to do is problems 1 and 2 today. That's all right. We can. So graphing just takes longer to do, right? So
James, can I ask a quick question?
yeah, go ahead.
For the left side of that graph, do you want us to find a point?
No, you can. You don't have to. Like if you're
Okay.
more comfortable saying like, okay, right, vertical asymptote's -2. So if I plug in -3, I definitely, if I'm going to plug in -3, I'm probably going to plug it into the factored form because it's easier to deal with. If I plug in -3, f of -3 is going to be 3. -3 minus 1 is -4. -3 plus 1 is -2. Divided by 2 times -3 plus 2 is -1 squared. So I get, let's see, so 8 times 3 is 24. 24 divided by 2 is 12. So I plugged in -3, I get the point -3, 12. You don't need to do that, but if you want to do that, you are welcome to do that. Let's go ahead.
So we won't get marked off if we don't do that?
Yeah.
Gotcha. Thank you.
But you do need to be able to, in one way or another, determine if the other side of the vertical asymptote is going up this way or going down that way. I did it by noticing that the vertical asymptote was an even multiplicity, so both sides go the same way. But if you prefer, it's totally valid to be like, oh, I'm going to plug in -3 and see what kind of value I get, if it's positive or if it's negative.
Gotcha.
One more quick example. Yeah. So this next example, there's something here that I want to point out that you don't really need to worry about. So this next example, which is graphing f of x equal to the square root of 2x minus 4 plus 3. Yes, this is a square root function. A square root function that has been shifted not 4 to the right, but 2 to the right, and been stretched or compressed horizontally by a factor of 2, and then shifted up 3. You don't really need to worry about all that. All you really need to know is it's a square root graph that's been moved around a little bit. We can figure out how it looks by finding the intercepts. So instead of trying to find kind of all the shifting, I'm going to say, what's my y-intercept? Set x equal to 0. Y is going to be the square root of 2 times 0 minus 4 plus 3, which is the square root of -4 plus 3. Oh, I can't take the square root of -4. There's no y-intercept. That's because 0 isn't in the domain of the function. If we want to talk about domain for 1 second, not that you have to say the domain unless someone asks you to say the domain, but the domain here, 2x minus 4 has to be greater than or equal to 0, so x has to be greater than or equal to 2. So that's actually a point I should consider, right? If x equals 2, even though that's not normally a point we're required to graph, since it's kind of where the graph is starting, it's an important point. So x equals 2, we're going to get f of 2 equal to the square root of 2 times 2 minus 4, that's 0, plus 3, we get 3. So the point 2 comma 3 is an important point. And we're also not going to have any x-intercepts, right? Because if you try setting this equal to 0, well, if you subtract 3 from both sides, you get the square root of 2x minus 4 equal to -3. That doesn't work either because square roots always give us positive results. It's still worth taking the time to think about, but we're like, oh yeah, we don't have that. So I know I've got my square root function. I've shifted it 2 to the right. and 3 up. Now it is horizontally compressed by a factor of 2 because of that 2 times x there. I don't really think about that when I graph it. If I was graphing this, I probably would throw in another point. I would probably pick something that's going to make the insides of the square root nice. So I know that if I plug in x equal to 2, I'm getting square root of 0 plus 3 to get the 0.23. I would love to be taking something like the square root of 1 or the square root of 4. Oh, the square root of 4 might be easy, right? So if I plug in x equal to 4, then 2 times 4 is 8. 8 minus 4 is 4. Square root of 4 is 2. So if I plug in x equal to 4, my y value is going to be 2 plus 3, which is 5. And then I can kind of just draw the square root function like that. So especially if you don't have any intercepts, it's often a good idea to kind of grab an extra point. But really, this function is mostly about seeing how it's shifted, right? It shifted 2 to the right, it shifted 3 up. Yeah, there's some stretching or compressing that we really just kind of capture by finding another point and saying, okay, the graph looks like that.